Alright, so in this video we're going to start with synthetic division. This is an alternative to the long division that we saw in the previous video, but I do want to note that this only works whenever you're dividing by something that looks like x plus or minus a number. So this wouldn't work to divide by something like x squared plus 1. In cases like that, you would have to use the previous method. But when you're dividing by just a linear term that looks like x plus or minus a number, then you can use this trick. This will speed things along a little bit, but you do have to be careful about the setup and the interpretation of your answer. So I'm going to go through this somewhat quickly, but what I would recommend is that if any of these steps start to confuse you, look at I think it's page 4 or page 5 of your notes. Those pages of the dividing polynomials notes have some typed up examples that you can read through slowly. But I think, as with long division, it'll be helpful to just go through a couple examples like this so that you can see what the general format is. So here's the idea. We want to compute x squared plus x minus 2 divided by x minus 1. Notice that our divisor is of the appropriate form, so we have an x minus a number or x plus a number. So we should be able to use synthetic division here. With synthetic division, we normally write things a little bit differently. We're going to write the division bar like this, so that it's sort of facing down rather than facing up. And here's what we do. For the divisor on the outside, instead of writing x minus 1, I'm just going to put the root of the divisor out here. So in this case, rather than writing an x minus 1 out here, I'm just going to write a positive 1 out here because that's the root of x minus 1. It's the thing that you would plug in to make that expression 0. So that's what goes on the outside. And then on the inside, we're also only going to be recording numbers, but we're going to record the coefficients of the dividend. And we should record them in descending order of degree. So I'm going to record the highest degree term here that has a coefficient of 1, and then the next degree down is also 1, and then the coefficient on the last degree term is a negative 2. So that's how I would write the setup for this problem. Okay, and now whenever you are performing synthetic division, notice that here the strategy is a lot easier once you sort of get used to the algorithm. What you do is you bring down the first number. So this first number is a 1, I'm just going to bring down that 1. And every time that you have a number down below this bar, you're going to take that number and multiply by your root out here to the left. So I'm going to take a 1 times a 1, and that's what goes in the next little entry down here. So I take the product of this times this, and that goes here. And then I add up this column. So I'll take a 1 plus a 1, that gives me a 2 now. Now that I have a 2 beneath the bar, I'll multiply that by the root. So I'll have a 1 times a 2, and that's what goes out here. And again, I just add up this column, and I'll get a 0. Okay. And now, whenever you have all of these numbers or all of these columns sorted, now we need to interpret our answer. In synthetic division, you can start with the first number here, and you'll take whatever the degree of the original polynomial was, and you'll decrease it by 1, and this will be the leading coefficient. So in this case, we started with an x squared, so a degree 2 polynomial. Our answer will be a degree 1 polynomial. In other words, our quotient will be whatever the original degree was minus 1. So we should have these as our coefficients on a degree 1 polynomial, which would be 1 times x plus 2. This will be our quotient. So in other words, these first numbers represent the quotient. The very last number will be interpreted as the remainder. So the remainder is equal to 0 in this case. So notice that that's a much shorter way to compute the quotient here, but you do have to remember how to go through all of these steps. So maybe before I move on to the next problem, let me just quickly review what we did. I'll just do it over here again. So what we do is on the outside of this bar, we write down the root of the divisor. On the inside of the bar in the top row, we're just going to record all of the coefficients of the dividend. So that was 1, 1, and -2. You bring down the first number, and then for each number that you bring down, you multiply it by the root out here. So this would be a 1 times 1. That goes into the next column, and then you just add up that column. So this would be a 1 plus a 1, which is 2. And then you multiply by the root, so that would be 1 times 2, which is 2. That goes into the next column, you add up that last column. This last number will represent your remainder, and then all of this stuff is going to represent the coefficients of the quotient. So this would be an x plus 2 if I were to write it like that. Okay, so that's synthetic division. Let's do one more example so that I can show you some complications that can come up here. So in B, what we're trying to do is we're trying to take x to the 7th plus x to the 5th minus 10x cubed plus 12, and we're trying to divide it by x plus 2. So this is a setting that we can use synthetic division in, because we're trying to divide by x plus or minus a number, so this is good. Now, the root of x plus 2 is not a 2, it's a -2. So we put a -2 out here. So that's one thing to be careful about with synthetic division. The thing that you want to set outside is the root of whatever the divisor is. Okay, and then on the inside of this bar, we're going to start recording the coefficients of the dividend up here. So we want the coefficients here. In synthetic division, though, it's important to record all of the coefficients, even if they aren't immediately visible. So the way that we should think of this divisor is as x to the 7th plus 0x to the 6th plus x to the 5th plus 0x to the 4th, and so on. So we do want to record all of the coefficients as we descend in degree, even if some of those coefficients are zeros. So the way that I would record this is 1x to the 7th plus 0x to the 6th plus 1x to the 5th plus 0x to the 4th minus 10x cubed plus 0x squared plus 0x plus 12. So this one will actually have 8 columns in total, because we're starting with a power of 7 and then 6 and then 5, 4, 3, 2, 1, 0. But the procedure, thankfully, is still the same. We're just going to bring down the first number, so that'll be a 1 down here, and then you multiply by the root. So we'll take a 1 times -2, that goes into the next column. And then you add up that column, so that would be 0 minus a 2, which is a -2. If I multiply that by a -2, I'll get a positive 4. If I add up that column, I'll get a positive 5. If I take that and then multiply by -2, I'll get a -10. If I add up the next column, I'll get a -10 here. -10 times -2 is a positive 20. If I add up that column, I'll get a positive 10. 10 times -2 is a -20. Adding up that column gives me a -20. -20 times our root is a positive 40. So we'll get a 0 plus 40, which is 40 here. And then 40 times -2 is a -80. And whenever we add up this column, we'll get a -68. And this last number will always represent the remainder. So whenever you do synthetic division, there's your remainder. And then the rest of these will be the coefficients of the degree 6 quotient. So notice that our original polynomial was degree 7, so these will be the coefficients on a degree 6 polynomial. So what that means is that our quotient is equal to x to the 6th minus 2x to the 5th plus 5x to the 4th. Minus a 10x cubed plus a 10x squared minus a 20x plus a 40. And the remainder is -68, as we saw a second ago. Now I know that that seems sort of complicated, but what you should remember is that if you were going to do this with polynomial long division, you would have 6 or 7 different lines that you would have to go through with a bunch of different multiplication and subtraction in each line. So this is actually much, much faster. The main issue is that you do have to be careful about going through the procedure carefully and interpreting your answer. But this is all that we get at the end. So we have a quotient and a remainder like we had in the previous problems.